Hello and welcome to Better Geology. I'm Andrew Dunning, and this is another installment in my ongoing series documenting my master's degree thesis research. So my master's degree requires a thesis to complete, and this is a research project which I am undertaking with a number of collaborators. The basic project is to figure out how old the most recent earthquake is on the Strawberry Mountains Fault, which was recently discovered in eastern Oregon in the Strawberry Mountains. If you haven't seen the previous episodes leading up to this, please go check them out before watching this episode, because this builds heavily on what I've already done. It's now the end of 2021, the end of December, and I have just finished all of my lab work I need to do for this year. If you recall the episode which documented my summer field work, it consisted really of two parts: collecting samples for cosmogenic exposure dating, which is what this big pile of bags is, and collecting charcoal samples in hand-drilled auger cores. I spent most of the autumn of this year sorting through bags of soil and petri dishes of soil and aluminum foil packets containing charcoal samples. Look at all of these. And I've almost gone mad doing it, but that work is all done as of right now. So as soon as I got back from the field at the end of August, I organized everything I had collected. The samples I collected with Kira, who is from Middlebury in Vermont, got shipped over there. That ended up being a little over 400 pounds of material that I had to ship across the country. That data was presented at the Geological Society of America conference, which was held right here in Portland this year in October. And my presentation of my in-progress research was a huge success, and I'm very proud of the work I presented, and a lot of people congratulated me on that, which was very nice to have. So because at GSA all I really had to present was that first preliminary cosmogenic age, I also presented on what I'm working on with this carbon-14 stuff. Early on, as soon as I got back, basically I drew a cross-section, let me grab that, which I created using the data from the different stratigraphic units I found when I was auger coring up at Onion Creek. Now this is the glacial till here. This is the up-thrown block, and down here is the down-thrown block. This is also glacial till. And in here we have the buried soil, a layer of volcanic ash from Mount Mazama. That's the formation of Crater Lake. This green here is sort of fill, alluvium, colluvium mixed in with that Mazama ash. And then on top we have the colluvial wedge, the deposits that were related to the most recent earthquake, and some other modern soil on top of that. This is a great cross-section. It not only looks good, but it helps tell a really good story that's going to help us analyze the data really well. Now this is all three versions of this cross-section I've made so far. This is the first one I did, and it's now sort of covered in notes. This is a cleaned up version I made for my Geological Society of America presentation, and this is the one I made today, which I'm just using to see my spatial distribution of the carbon-14 charcoal samples that I've collected. And while I was out there coring, I collected quite a lot of samples of soil from the auger cores. All of these gallon bags full of dirt came from the Strawberry Mountains. I had to dry them all out so that I could describe their color accurately using something called the Munsell Color Book, which is a standardized set of basically soil colors. Some of them look nicer than others. This one is a nice deep red. This is the very base of the buried soil. This is the most recent earthquake colluvium. It's really light and fluffy. In some of my notes from the field, I just described it as brown fluffy. Notes get lazy by the end of your fieldwork trip. But these have been enormously helpful because I've managed to sift through a couple of them underneath the microscope and recover actual charcoal samples, some of which I included in my first batch of samples, which are all right here now. I'm going to load them up into a box and mail them out hopefully tomorrow after I film this, and that's very exciting. I've spent an enormous amount of time right here at this microscope going over pieces of charcoal I collected individually in these little foil pouches, and also looking through bulk soil samples like this little bag here. This one has been sorted. I looked through every inch of this soil in the microscope using all sorts of different tweezers and scrapers and pokers to find more pieces of charcoal that I could use to estimate the age of these different soil units, which in turn helps us estimate, constrain is the word we use, the age of the most recent earthquake. I'm hoping to dredge up some more grant funding in the spring so that I can run a few more carbon-14 samples, because the more data, the better. And I can only afford to do 12 right now, so if I'm able to get more, then that's good data too. I even collected a few samples that are okay samples, but I've elected not to send them in this batch because, maybe I'm not confident in them. Maybe they're too small. They were not optimally located for the kind of analysis we're going to need to do. They're different pieces from the ones I'm mailing in, but they're from the same stratigraphic location, the same depth below the surface. So if any of these turn out to be funky or unexpected ages that don't really make sense, then I have other material from the same location that I can use and test that to get a more reliable age for that depth. Now I'll go back to the carbon-14 and show you a little bit how it's done. So I'm about to start working on my final charcoal sample before mailing these all out to Woods Hole Oceanographic Institute at the National Ocean Sciences Accelerated Mass Spectrometer. Quite a name, right? Which is one of the best carbon-14 dating labs in the country, so that's where I'm sending mine. And this is the last one I'm going to send and select. All right, here's the packet. It's a Onion Creek core number 7 from 69 centimeters depth. This is right in the middle of the ashy colluvium layer that sits above the Mount Mazama ash layer and below the most recent earthquake event horizon, which is the period in time in which the most recent earthquake occurred. So this will be sort of a good constraining factor for the age of that specific unit, that ashy colluvium unit. And I'm opening it now for the first time since I collected this one in August. Either way, my first step is to clean this petri dish. Since I already used it to look at some other charcoal samples, I now have to clean it to make sure there's no additional residue from any of those previous charcoal samples, because that can very easily contaminate and skew the final results. This petri dish is now as clean as it needs to be for opening up charcoal samples. Here's how big this packet is. Kind of looks like that. Not much to see. So I really don't know what I'm going to find inside since I haven't opened it in 4 months, nearly. Rolled this one up real tight. Alright, and inside, oh wow. Quite a bit of charcoal in there. Let's see. There you go. That's what it looks like. So right out of the sample bag, they're kind of muddy, but you can see there's quite a few pieces in there, so I found quite a bit of charcoal in this particular auger core pole. So that's good news. That means I can select the best looking sample out of all of these. So I'm going to pour them all out onto this little petri dish I just cleaned, or a watch glass, I guess it is. Now I look at it under the microscope to see how they all look. Okay, so I'm looking at this really big one. Okay, it looks good. It's quite large, maybe very nearly a centimeter across, just a rough estimate. Maybe 5 millimeters wide, very angular, which is important because that means it has not traveled very far from wherever it fell after this charcoal was burned. I do like what I'm seeing. A lot of this looks ideal. The wood grain is very well preserved on this piece. This piece of charcoal could easily be 5,000 years old, and you can still make out the cellular structure very easily. Okay, there's another piece here that's similarly shaped. I don't know if it was originally part of the same piece and it fractured, or what exactly happened there, so I'm going to have to ignore that for now. There's a lot of other good pieces in here. So these ones are nice because they're covered in the surrounding sediment that they were found in, which is a sort of a mixture between the local glacial rock flour dusty dirt and volcanic ash from Mount Mazama, because this is a soil layer that developed on top of that Mazama ash, so there's going to be pieces of it throughout. But the wood grain is very well preserved. They're all quite angular. There's a lot of charcoal in here, which is good. That means I can pick whichever one looks the best. A lot of smaller pieces in there, kind of dust-sized. Less than a millimeter, which is too small. And I don't really need to bother with that when I have so many other larger pieces. So I'm going to take this big one out, set it aside, and put all of the rest of this back in the little sample bag it came in, which is not ideal, but it's good enough for now. Okay, now, so this piece is pretty dusty and dirty and covered in mud. So I'm going to spend the next little while scraping it clean, then I'm going to weigh it, and then take a picture of it using the dissecting scope camera in the other lab room. And that's basically the process. I've done that for all 11 samples I've collected so far, and this will be number 12, and that is all I currently have the funding to afford to send to the lab. And hopefully I'll get good data back. You'll find out in a couple of months when I get it back. So that's where I'm at with my research as of the end of December 2021. If the stars align and everything continues to look good, I will be able to finish up this project by June and be done with my master's degree, which is an exciting prospect, even though I really like doing this kind of work and doing this kind of research. Well, that's all I have for it today. My name is Andrew Dunning. This has been Better Geology, a part of the Terra Incognita series documenting my master's thesis research progress. Thank you very much for watching once again, and goodbye.